Hello, welcome to another chemistry lesson with Daniel. Today we're going to be learning about the main parts that make up the atom, and those are known as subatomic particles. The only three subatomic particles that make up the atom are the protons, neutrons, and electrons. Protons and neutrons make up the main mass of the atom, and they reside in the center of the nucleus, or the center of the atom, which is known as the nucleus. Electrons, meanwhile, reside in the outside part of the atom that orbit the nucleus. Meanwhile, between the nucleus and the electrons, there exists only empty space. So, firstly, if we were to take the nucleus and make it approximately the size of this circle, the furthest electrons from this nucleus will be far outside of this room. So that shows you kind of how far the electrons are from the main nucleus. However, though, the mass of an electron is nearly inconsequential to the overall mass of the atom. So for ease and for calculations, we simply count the electrons as 0. Protons and neutrons, meanwhile, both have about an equal mass. So that's what we use to calculate the mass of the atom. We make protons equal to 1, as well as we make neutrons equal to 1. Now, the original idea was that the atom was indivisible. You could not divide this down any further than right here. Now, however, we know that you can divide it down further into these 3 particles. Now, how scientists have viewed how the atom is made up of these 3 particles has changed over time. Our most recent model, the electron cloud model, is the most accurate model ever created, and it states that the mass of the atom is concentrated in the nucleus with protons and neutrons. Meanwhile, and the electrons exist in electron clouds around the atom. So instead of elliptical orbits going one way, electrons can exist anywhere inside this electron cloud in what we call orbitals. This electron cloud would be known as an orbital. And as you go up the periodic table, the bigger the atom, the more protons the atom has, the bigger the electron clouds. Previous models do include things like the Bohr model, which was the previous model before the electron cloud, where it believed that electrons traveled in nice elliptical orbits, such as this. Now, another part of the new electron cloud model is that as you go farther away from the nucleus, you go into what's called a new energy level, as it requires an electron a certain amount of energy to jump from this orbital to this one up to a new energy level. And we'll be able to get into how electrons move around in those electron clouds a little bit later on. So, on to how we describe how we can tell how many protons and electrons are in an atom. So, let's take potassium, for instance, like that. The amount of protons that it has is 19. And let's say it's been charged. So we have a positive 1 charge up here. Whenever you're writing a nuclear symbol for an atom, you put the element in the middle, number of protons on the bottom left, the charge goes top right, and then the overall mass number goes in the top left. Mass number consists of the number of protons plus the number of neutrons. So let's say the potassium had 2 more neutrons than it has protons. It would have a mass number of 40, such as this. So this would be a complete nuclear symbol for a charged ion of potassium. This is a positive charge, obviously, and this can be done with any other charge, for example, chlorine, which would have a negative 1 charge right here. And that concludes another chemistry lesson with Daniel.